Now we look at self-practice 7.2c. So it's about the manufacturing factory that producing the ball. So they need to regulate the internal air pressure in PSI. What is PSI? What is PSI? Pounds per square inch is the unit measurement to measure the air pressure and also the water pressure. Okay, pounds per square inch. Okay, so over here they gave you the machine already, machine P and machine Q over here. They ask you to find out which machine show better performance in terms of air pressure accuracy. Anything happen here? So you see the factory specified that the internal air pressure of a ball should be between 11.3 pound per square inch to 11.7 pounds per square inch. So they ask you which one shows better performance. Okay, so from there, you have to construct your frequency table. So this is what I have over here, frequency table. This one you just copy down everything. Add on the x, x squared, fx, and fx squared. After that, you find the total f, total fx, and total fx squared. So from two of the table that I have for the frequency table for machine P and machine Q, this is the table over here. This one is machine Q. So we found out the mean is 525.5. You check your total whether it's correct or not. 525.5 over the total frequency is 50. So we have a mean of 10.51 exactly. And then the standard deviation, it will be 5611.825 over 50 minus 10.51 squared. So it's 1.33. Whereas for machine Q, the mean is 582.5 over 50. So it is 11.65 exactly. Standard deviation is 6840.125 over 50 equal to minus 11.65 squared. So the answer is 1.04. So from here, firstly, we have to compare the mean. The mean for machine Q is 11.65, whereas for machine P is 10.51. So if we refer to the question over here, the factory specified that the internal air pressure of a ball should be between 11.3 psi to 11.7 psi. So which one is better in that case?
Machine Q.
Yes, correct, machine Q, because the mean is within the range stated. And also the mean is higher than machine P over here. So the answer is machine Q shows better performance in terms of air pressure accuracy. Why? Because the mean lies between the range, within the range. And if you compare the standard deviation, this is 1.04, this is 1.33. The lower the standard deviation, the better. Shows that it is more consistent. Okay, so the smaller the standard deviation, show that it is more consistent. Okay, is the answer correct for both the mean and also the standard deviation?
Yes.
Yes, then I move on to the second question. So this is the second question. Okay, it shows the lifespan of battery X and also battery Y. So you were asked to use a suitable measure, determine which brand is better and last longer. So for sure, the measure over here that we are going to use is the mean and also standard deviation. There are many types of measure, right, that you have learned, like range, interquartile range, variance, mean, and standard deviation. So the most appropriate one over here is the mean and standard deviation. Okay, so from there, you construct the frequency table for both of the battery X. This is the frequency table. Make sure your total is correct over here. Total F 60, Fx is 167, and total Fx squared is 540.15. Then for battery Y, it's 60, 126, 350.25. Okay, this one's supposed to be the same, although the frequency is different for each of the classes. Now, from battery X, we found the mean 167 over 60 is 2.78. Okay, but then there are more decimal points at the back. So the standard deviation will be 540.15 divided by 60 minus the mean from here. We cannot use 2.78 because this is This is not the exact value. We have rounded it off. Okay, so we will get 1.12 for the standard deviation. You check. Then for the second one, battery Y, the mean is 2.1. Okay, 2.1 is an exact value. So in the standard deviation, you can use this to minus the mean squared over here. So it is 350.25 over 60 minus the mean squared, we get 1.19. Okay, then you compare. Compare the mean. Of course, the mean, the higher is better. So over here, battery X, the mean is better than battery Y. And then when you compare the standard deviation, the lower the better. So the standard deviation for battery X is better than battery Y, meaning that this battery from the mean, it lasts longer. And then this standard deviation means the lifetime is more consistent. That is how you answer the question. Okay, so if you really don't know how, you can refer to the back of the book. Brand X battery is better because the larger mean implies the longer lifetime. And the smaller standard deviation implies the lifetime is more consistent. Okay, do you have any question, class?
Madam,
Yes?
what if we don't do the table at all? Like we just
You
straight
don't
away
do the
use the
table.
calculator. Yes.
Okay, if you don't do the table, do you have the calculation, the working like this?
Yes.
Yes, can, no problem, as long as you have the working like this. Okay, you don't
Oh,
jump
all right.
directly into the answer for me only. You don't jump directly here. You need to show me, because in your calculator, you can get the total fx and total f, right?
Yes.
Same thing with your total fx squared, and also here in this part, you can get everything. So make sure you have the working. If you don't have the working, I think no mark will be given. Okay?
All right. Thank you,
Any
madam.
other question? Yeah, you're welcome. Any other question?
No, madam.
No. Okay, we proceed to problem solving today. So this is the one, example 13, problem solving. This is the second last part. Okay, let us look at example 13 here. A survey of the duration of time in hours spent by customer to buy goods in a supermarket is carried out. So when you go to supermarket, do you take long time? Previously, yes, right?
Yes.
Now I think your parents have to rush, buy everything, after that pack up everything, go home straight. Okay, now you can see how much the time spent by the customer when they were in the supermarket. The results of the survey are shown in the ogive on the right. So you can look at the ogive. A, construct a frequency table for the time taken by the customer to buy goods in the supermarket using the class of 0.5 to 0.9, 1.0 to 1.4, and so on. So you can see over here the total of the classes that we have are 5 classes. Okay, now you remember previously when we want to construct ogive, we need to have our frequency table, right? After that, you find out the cumulative frequency. That's why we have cumulative frequency on the right. So now you are given the ogive, it's turning back. You are doing it backward. You are given the ogive, you need to construct the frequency table. So how to do that? I'm going to show you the frequency table over here. It's not here, frequency table. Okay, this one. So this is what we have from the 5 classes given at first. Now you have to figure out these 5 classes represent what? What is the title for the 5 classes over here? So refer to this. If you refer to the graph over here, this is the time in hours. So you can see the boundary over here. After that, this is the cumulative frequency, time spent by customers. Now, for the classes 0.5 to 0.9, what do they represent on the first, on the classes over here? This one. What should I write? This one for sure is a frequency, right? The frequency is referring to the number of customer. You see, the customer. Okay, the cumulative frequency over here is the total already, right? So it represents the number of customer. Meaning, the first column is represented by the x-axis. That is the time in hours. Okay, so that is how I fill up the frequency table over here with time in hours. And then the next one will be number of customer. Okay, so I enlarge it. Now, from 0.5 to 0.9, refer back to this. Okay, you see, from 0.5 to 0.9, actually the first one over here, last time when we want to construct our jive, in the frequency table, we have to add another class before so that it doesn't float on top without this. We add a class before. So over here right now, we are not going to see the first class anymore because this is the one that we added before, so that the cumulative frequency start from 0. So we are going to look at this is considered the first class that we have. Okay, which means 0.5 to 0.9 over here. Okay, we are going to refer to this point. That is the upper boundary. You can see from here, the upper boundary of it. So I enlarge it. You are going to read how much is the cumulative frequency for 0.95 over here. So we go up, move to the left. Here, if this is the point, this is 20, half of it is 10. So this will be how much? Can you see the reading? If this is
6.
10, this will be 6 because this is 2, 4, 6. So this will be 6. So we are going to get the reading for all the upper boundary to represent each of the class. So this is the first class. This will be the second class. So you go straight to the top. Okay, move to the left. So this is the point. How much is it? If this is 20, this will be
22.
22.
22, correct. So this is 22. Okay, you have to show your arrow using the dotted line like this. I didn't show it to you. You have to show like that every time from your reading because that is the way to show how you get the answer. Same when you want to draw it in, when you want to find out in your SPM later on, you have to show this. It's compulsory. I noticed some of you didn't show this, so I give you a comment in your GC over there. You have to show your arrow. Okay, the next class right now will be 1.95. This is the third class. So you move it up. You can see from here, and then move it to the left. The reading for this one is 50. How much is this?
54.
Yes, very good, 54. The next one, this is the fourth class. Okay, this one is easy to read. How much is this?
70.
70.
Yes, very good, 70. And the last one, 2.95. So I move here. This is the fifth class. Okay, this one easy. Directly, you get it from there, 80. Okay, so we have all the value already, which is 80, 70, 54, 22, and 6. All the 5 classes. But this is the cumulative frequency. We can't fill our frequency table with cumulative frequency over here because they want frequency table. So for the first class, we need to find the frequency over here. Means we have to deduct it because 22 is the cumulative frequency that you already added with 6. So now to find the number of frequency over here is actually 22, you minus 6. So you can get the frequency here in the middle. Okay, so 22 minus 6, how much is it?
16.
Yes, 16. That is on this class over here. Okay, so means the first one is 6. Your frequency start with 6 over here. So over here in your frequency table, I'm going to start with 6. Okay, and then just now you found out 22 minus 6 is 16, right? So this will be the second one. You can see the range 1.0 to 1.4. So it is 1.45 in the cumulative frequency, this one. Okay, so next one, to get the next one, you will have to use 54 minus 22 to get the frequency over here. 54 minus 22 is
32.
32. So we put input the answer for the next one, 32. And then go back again. The next one, 70 minus 54 is 70 minus 54 is
16.
16. Okay, and the last one, if you refer to the last one here, easy. 80 minus 70 is 10. Okay, so we have done our frequency table already. This is the one. First part. This is for A. Okay, A is done. Now you look at B. B, we have to estimate the mean and standard deviation of the data. So you got to remember, when you want to find the mean, you will need the total fx over total f. And then to find the standard deviation, you have to go through all of it, right? So what you do is you construct the frequency table, not the frequency table that include all the midpoint and so on. Or else you can use what?
Calculator.
Yes, calculator. Okay, so do you want to use calculator or you want to construct the table? I let you choose. Construct the table so that you can see the amount, the value easily. So I move down over here. So this is what I have, 6, 16, 32, 16, 10. I think I've already get ready for you. Okay, this is the one. So I copy down everything down here. You can see 6, 16, 32, 16, 10. Okay, the total frequency is 18. So we are going to finish up this part over here. Midpoint. What is the midpoint? 0.5 plus 0.9 divided by 2, we will get
0.7.
yes, 0.7. So we just carry on over here. This is 1.2 is the middle value of this. Continue by 1.7 and then 2.2 and 2.7. Okay, so fx, I have the value already. X from f multiplied by x, I get this. X squared 7749, so it's correct. Fx squared 0.49 times 6, we get 2.94. So these are the value. Okay, so from here, we can get the mean already. We move back. Okay, this one is in your book. Now, we are going to find the mean. How to get the mean? Mean is equal to how much? The total fx, right? 140
Yes.
over
Sum
the
of
total
f.
x. Correct. Sum of x is 80. After that, you are going to calculate. So 140 divided by 80. You can check. 140 divided by 80. Oh, sorry. Is equal to 7 over 4. That is 1.75. Sorry. Okay, our first mean already done. Then we need to get the standard deviation. You have to always show this. Standard deviation using the symbol is the square root of total fx squared, which is 268.8 over the frequency 80 minus the mean squared. Just now the mean is an exact value, right? 1.75, so we just use that. If it is not exact value, then you have to use the fraction here. Okay, so calculation time. 268.8 divided by 80, you get the answer. After that, minus 1.75 squared. Get the answer. Square root the answer. So the answer will be, how much is this? 0.5454. So round it off to 2 decimal places. It will be 0.55. Can you see? Because we add 1 to the left. Okay, now we have got our standard deviation and mean. Now refer back to the question. Is it done? They just ask you to estimate the mean and standard deviation of the data. So it's done already, that's all. Do you have any question?
No.